Dependent and independent variables. A little bit more language here. The input variable is also referred to as the independent variable, and this makes it easy to remember because they both start with the syllable in. The output variable is the dependent variable, so called because it depends upon the input. The input determines what the output will be once the function is defined. So in our example, we have a function h of t, which represents the height h of a model rocket in feet t seconds after launch. We have a dependent and an independent variable. Remember, independent is the input and t is our input. So t is our independent variable, and I'm going to indicate that it's the variable t and what it means. T is the number of seconds after launch. And then by process of elimination, the dependent variable is the other one. This is h, and h represents the height of the model rocket in feet. Okay, so now that we have identified our dependent and independent variables, let's go on to the next part. We're asked to evaluate h of 2, and remember this means referring to the function named h, and 2 is my input. Therefore, I'm going to plug 2 in for the variable t, which gives me h of 2 equals -16 times 2 squared plus 64 times 2. Following order of operations here, we would do the 2 squared first because it's an exponent. This gives us -16 times 4 plus, it's okay to go ahead and do this also at this time. 64 times 2 gives me 128. Now -16 times 4 is -64 plus 128 gives me 64. So we've evaluated h of 2. We have the statement h of 2 equals 64. And to explain its meaning, we're going to have to use each of these numbers in a sentence together with units. So let's put this more central on the screen. We already determined that h is the height. Let's look at that definition. H is the height of the model rocket in feet. So that h tells us the height of the rocket. This 2 tells us that the value of t is 2, so this is after 2 seconds. Is, now we use our 64, and we've already determined that the height is measured in feet, so we're going to use the number 64 at the end of our sentence to say the height of the rocket after 2 seconds is 64 feet. Next we go on to evaluate h of 4 and explain its meaning. We're going to do the same thing to start. I'm going to plug in the value 4 for the variable t in my function. Which gives me, again doing the exponent first, negative 16 times 16 plus 64 times 4, which is, if we bring in our calculator, 64 times 4 gives me 256. And 16 times 16 also gives me 256. So this becomes negative 256 plus 256 equals 0. So to explain its meaning, we have the statement h of 4 equals 0. We could start by translating from left to right like we did in the last example and say the height of the rocket after 4 seconds is 0 feet. But if we think about that for a moment before we start writing, we can interpret it with a little bit more depth and say, oh, it looks like after 4 seconds the rocket has returned to the ground. So that's how I'm going to choose to explain its meaning. Again, anytime we're asked to explain the meaning after evaluating a function, to explain the meaning or to interpret, what we're really looking for is the numbers being used with the appropriate units in a sentence that explains what they mean in the context of the problem. So here we made sure to use the height of the rocket, the number 2 with its units of seconds, the number 64 with its units of feet, everything together in a sentence that makes sense.